Hi, it's Ms. Hochstetter to go over the distance versus time graphs. So in Unit 2, this unit is really heavy on reading graphs, so usually distance versus time graphs or even sometimes velocity versus time graphs. For this one, we're only going to be looking at the distance versus time graph. So here's our graph. And then number 1 says determine the distance of the car at 2 seconds. So this is just a basic graph reading skill. So we're going to look at time, we're going to look at 2 seconds, and if we go up, we see that 2 seconds hits here, and then if we look to the left, we see that it is at 9. So the distance that the car is at 2 seconds is 9 meters. So what's nice about that is it's really just looking at the graph and reading it. Number 2 asks for the displacement of the car at 2 seconds. So displacement you might need to remember from vocab. So over here I have the definition or a definition of it. Displacement is the distance traveled from the origin. So if we look at the origin, it's right here and it started at 5 meters. So it didn't travel 9 meters total from the beginning. It actually started a little bit further ahead of the origin of this graph. So it actually started at 5 meters, and it got to 9 meters. So 9 meters minus 5 meters is going to give us our answer, which is 4 meters. And if you want to think about that, if this were like the timeline, right? It's on that. If this were the timeline of 0, it actually started at 5 meters when the time started, and it started moving this direction towards 9 meters. So in 2 seconds, it traveled that far. So that's how we came up with that 4 meters number. Then, number 3, it says find the car's velocity. So the velocity is the rate that the distance changes. So it's going to be the slope of the distance versus time graph. So if we look at this, probably the best way to do this is to just find the normal slope. And so to do that, I like to use the equation from Algebra 1, y2 minus y1 divided by x2 minus x1. But you can also, do your normal like rise over run methods from Algebra 1. So I'm going to just pick 2 points that are really easy to do. So I'm going to pick this point since we already know it. And you know what? I'm just going to pick the origin as well, because we already kind of know that one as well. So if this is my y, so this point is 2, 9, and this point is 0, 5. And so this is y2, this is x2, this is x1 and y1. So I'm going to substitute those numbers in. So 9 meters minus 2 meters. Oh, no, sorry, not 2. Minus 5 meters divided by 2 seconds minus 0 seconds. So that would give me 4 meters divided by 2 seconds. And that would give me 4 divided by 2 is 2 meters per second. And that would be my answer for this. And what I want you to notice is that the units, right? So my y values, that's my distance. And so they're always measured in meters. Okay, so meters is always on the numerator. And then if you look at my x values, that's time, okay? So that's going to be my values here. So it's in seconds. So when we do meters divided by seconds, my total units at the end of all of this are going to be meters per second, which you notice is what velocity is measured in for physics, meters per second. So that is also just a nice way to see how the units work. With this, the slope of that line of a distance time graph is velocity. So slope of a distance time graph is velocity. Okay? That's something that's just going to become really, really, really helpful for you moving forward. So that's kind of the big takeaway from this.